Hi everyone. Today we are going to explain document 2 of chapter 1, which is about the nervous information, its nature and propagation. Page 60-61. First of all, I'm going to ask you a question. Do you think there is electricity in our body? Of course, yes. The nervous message, it represents an electrical signals which can be recorded by an instrument or by an oscilloscope. So you have to know that all our actions, they are controlled and they are enabled by electrical signals, okay, which are running throughout all our body. So the nervous information, okay, its nature, if we are asking about its nature, it is an electrochemical message where an action potential is an electrochemical wave at the level of the neuron. So yes, there is electricity and it is represented by the nervous message, which is an electrochemical wave. First of all, we are going to talk today about an electrical phenomenon, or about the first potential, which is called resting potential. You will be able to identify the origin of the resting potential, and you have to be able to distinguish between resting potential and action potential. First of all, this figure in your book, the first figure, what do we have? It is showing you a non-stimulated neuron in the state of polarization. We have a voltmeter. Yes, its two electrodes are connected to the non-stimulated neuron. First of all, before reading the text, let me ask you a question. What do we mean by non-stimulated neuron? A non-stimulated neuron, it means that this neuron is not subjected to any stimulus. And what do you mean by stimulus? Stimulus, it is any action that you might be subjected to which will make you to react. For example, you might be subjected to a thermal stimulus. For example, touching a hot object, this is a stimulus. Or being pricked by a pin, this is a stimulus. Okay, so a non-stimulated neuron, in this case we are talking that when a neuron is at rest, it is not stimulated, there is no stimulus, as if I am saying when you are sitting and you are not subjected to anything, no stimulus at all. Okay, how is the state of the nerve cell when it is at rest, when it is not subjected to any stimulus? Let us see how is the state of such a neuron. A non-stimulated neuron possesses a membrane potential or resting potential. So resting potential, it has another name, we call it membrane potential. That is approximately equal to minus 70 millivolt. The negative charges indicates that the interior is negatively charged in respect to the exterior. So here it is the definition of the resting potential, but I'm going to explain it in more details in order to understand it. The resting potential is the result of a difference in ionic composition between the intracellular and extracellular fluid. Na plus predominates at the exterior and K plus at the interior. All this text, it will be explained by the experiment that I'm going to show you in the next slide. But before, if I asked you to draw out from the paragraph the difference that exists between a neuron at rest and a stimulated neuron. So first of all, I want from you to know the difference between a neuron at rest and an activated neuron, or neuron subjected to a stimulus or stimulated neuron. At rest, it means the neuron is polarized. What do you mean by polarized? It means equilibrium in charges. There is equilibrium in charges along the sides of the membrane, where a difference of potential exists between inside and outside of the neuron's membrane. And now you will see with me, look at this figure. Outside, which charge predominates, it exists, in other words, in high concentration. Look, outside we have the positive charges and inside we have the negative charges. So when the neuron is at rest, when you are not subjected to any stimulus, okay, we have equilibrium in its charges. Okay, what do I mean by this? I mean by this that at the outer surface, look at the extracellular medium, please, or outer surface, we have high concentration of positive charges, and inside we have high concentration of negative charges. So this is what represents resting potential, the difference in the charges between inside and outside. Inside is negative and outside is positive. So there is an equilibrium in the charges along the sides of the membrane. Why do you think the same state we obtain or we have when we are subjected to a stimulus? Of course, no. While the stimulated neuron is depolarized, in other words, okay, once the neuron is stimulated, there is a production of an action potential where the resting potential is reversed. Here the charges will be reversed. What do I mean by reversed? They become the opposite. Inside becomes more positively charged than the outside, that's due to a stimulation. Now, in order to understand more what do you mean by resting potential, please, I want you to focus on such experiment. It is very important, okay? First of all, what do you mean by polarization? Polarization, it is the equilibrium in the electric charges along both sides of the cell membrane of the axon. Let's consider we have an axon. This is an axon. Look please at the figure. This is an axon. Okay, if you notice here, we have equilibrium in charges. What do I mean by equilibrium? We have balance. All the outside charges are positive and all the inside charges are negative. So there is a balance between them. Okay, that is all the surface charges are positive and all the cross-section charges are negative. When do we talk about such a state? I'm asking you, in which state do we talk about polarization? You have to know when you are at rest. When you are not subjected to any stimulus, there is polarization. Now look at these experiments and try to understand the origin of resting potential. What do we have? First of all, we got an axon. Okay, they are showing you the axon. Okay, we got a voltmeter or galvanometer. It's checking the voltage, and its electrodes are placed in different places along the three experiments. If you look at the electrodes, they are presented by the blue arrows. In the experiment 1, the electrodes are both on the surface. In experiment 2, the electrodes are both inside the axon, and in experiment 3, one electrode is inside and the other one is outside. Do you think we will obtain the same voltage in the three experiments? Of course, no. Let us explain the result. When we got a voltmeter and we are checking the voltage along the surface of the axon, look, what do we have when the two electrodes are placed on the surface from outside? What was the result? 0 millivolt. What do we got? The needle of the galvanometer, it indicates 0. What does it mean? I'm going to ask you a question. 0, does it mean that there is a flow of electrons or no? Of course, there is no flow of electrons. In other words, it means that all the surface charges, they are identical. They are the same. There is no potential difference between the surface charges. So since the needle of the galvanometer gives 0 millivolt, this means that all the charges along the surface, they are the same. There is no difference between them. Okay, so they are all positively charged. Okay, so till now you've recognized that the surface of the axon, the outer surface, it is positively charged. What about the inside of the axon? What about? Let's move to the second experiment. We have an axon, the same, okay, but different figure. Okay, the two electrodes now, they are placed inside in the intracellular medium of the axon. Look at the galvanometer. What does it indicate? It gives 0 millivolt. What does it mean 0 millivolt? It means the same, that there is no flow of electrons in the inner wall of the axon. In other words, all the cross-section charges or all the charges in the inner membrane of the axon, they are the same, they are identical, it means that all of them, they are what? Negative. So inside they are all negative and outside they are all positive. For that reason, there is no potential difference between the surface charges, neither between the cross-section charges or the inner charges along the axis. Now I'm going to ask you a question. Do you think there is a difference in charges between outside and inside? Yes, and that's clear. If you see what we got in the first experiment, all the surface charges, they are positive. And all the inside charges, they are what? Negative. Now let's move to experiment 3. Let's see what happens when we put one electrode inside in the intracellular medium and the other electrode outside. What will we get? If you notice that the voltmeter gonna indicate minus 70 millivolt. What do you mean by this? This means that inside is more electronegative than the outside by 70 millivolt. So inside is more electronegative than outside by 70 millivolt. And this what refers to the value of the resting potential. The value of the resting potential is equal to minus 70 millivolt because there is a difference in charges between the surface and inside. Okay, so there is a flow of current from the surface to the cross section. Okay, so what have you concluded till now? We conclude that when the neuron or when the nerve fiber is at rest, okay, there is a difference in the charges between the outer and the inner wall of the axon, where inside is more electronegative than what outside. By how much? By 70 millivolt. For that reason, minus 70 millivolt refers to the value of the resting potential. So if I ask you what is the value of the resting potential, it is equal to minus 70 millivolt. What does it mean? It is the potential difference between the surface and the cross section of the nerve fiber. It is the difference in charges. Okay. Now I ask you to interpret the results. So as I said before, what does interpret require? In order to make an interpret for an experiment, what do we need? We need to make analyze, as well as we need a significance or relation. And in order to analyze, we need to know the variable and the result. What was the result? The result was revealed by the needle of the voltmeter. Here it is 0, here it is 0, and here it is equal to minus 70 millivolt. And with respect to the variable is about the electrodes of the galvanometer or the voltmeter. In experiment 1, they were placed on the outer wall, and in the second one they were placed in the inner wall of the unstimulated neuron or axon, and here one is outside and one is inside. So after determining the variable and the result, we will be able to make an interpret. What do we have for the interpret? We say in experiment 1 and 2, the needle of the galvanometer indicates 0 millivolt. Look at the needle here as well as here. It is 0 millivolt, where both electrodes of the galvanometer are placed on the outer wall of the unstimulated axon. I repeat, the state of such axon is at rest. In other words, it is not subjected to any stimulus. And both electrodes are placed in the inner wall of the unstimulated axon in experiment 2. What is the significance that should be concluded from both 1 and 2? This indicates that the electrodes in each experiment 1 and 2, they have the same charge. Here on the outer wall we have the same charge, and inside we have the same charge. In other words, there is no potential difference. Whereas the needle of the galvanometer indicates minus 70 millivolt when one of the electrodes is inserted in the intracellular medium, when one is inside. Thus, there is a potential difference between the outer wall and the inner wall of the axon, and the value is equal to minus 70 millivolt. And as a conclusion, we can conclude together the definition of a resting potential. What is a resting potential? So you have to know that when you are at rest, the nerve fibers, the axons, there is a difference in charges between inside and outside, and this is what refers to resting potential. So the definition of resting potential, it is the potential difference between the intracellular and the extracellular medium of a neuron or axon at rest. Don't forget that at rest, where inside is more electronegative than outside by 70 millivolts. As a conclusion, the nerve cell is polarized at rest. Outer wall is positively charged and the inner wall is negatively charged. So when I ask you what do you mean by polarization, it means equilibrium in its charges. Outside all of them they are positive, and inside all of them they are negative. Minus 70 millivolts is the value of the resting potential. If I ask you to indicate the value of the resting potential, it's equal to minus 70 millivolts. The minus charge indicates that the intracellular medium is more electronegative than the extracellular medium. How do neurons operate? You have to know that we have two states for the neuron. When the neuron is at rest and when it is subjected to a stimulus. For today, we are discussing together when the neuron is at rest. In other words, we are discussing the resting potential. When do we have resting potential? It occurs when the neuron is at rest. Don't forget the state of the neuron. It is at rest. And a resting potential, it is a condition where the outside of the membrane is positively charged compared to the inside, which is negatively charged. In this case, we say that the neuron is polarized and it has a voltage difference of minus 70 millivolts. Finally, this what reveals the origin of a resting potential. The resting potential, okay, it is due to the difference in the ionic distribution. As I said, you've seen that this is an axon. All the outer membrane charges, they are positive, and all the inside this are negative. This difference in the charges on both sides creates the resting potential. And also we have the differential permeability of the plasma membrane. In other words, the outflow of K plus is more than the inflow of Na plus. You have to know that outside they are all positive because sodium exists in high concentration, while inside we have potassium in high concentration, and this differential permeability creates the resting potential. And it is not continued. Why? Because we have a pump called sodium potassium pump, okay, where the initial electrical equilibrium is restored through moving Na plus from inside to outside and K plus from outside to inside. And that's what is all about the origin of resting potential. Now we will move to the action potential, but we will discuss it in details in the second lesson, in the second session.